not 1.3. What does that mean?
Yeah, good question. You don't have to worry about that. That means where it got it from the original hard copy book.
Oh, okay.
Yeah, you don't have to pay attention. We'll just look at it right here is where we're looking. 1 of 20. So that means there's 20. So this is the first homework section. There's 20 questions in the section, and this is problem number 1. This is actually, it already has an answer there, doesn't it?
Yeah,
So I'll just show how we got that answer, which you already know. So I'm going to literally solve the problem right now with you. You take notes. And when you come to this question, it'll be the same question with different numbers. So I'm literally going to do your homework with you. And these will turn into test questions, just like them with different numbers. So there's the formula. Area equals a half times base times height. That's the formula they're giving me. I'll give you the formula right on the test. And then they're telling me, okay, base is 25, so you plug in, you put parentheses around things that you plug into a formula. And the height is 40. Is that good so far? I'm just plugging in the base, plugging in the height, 25 and 40, like that. At this point, you can just use a calculator. Calculators are fine on the homework and the tests and everything. That's fine to do, yeah. Oh yeah, good question. It's just meters. You don't have to do anything with the units. All we need is the numbers. The end is the meters. All right, so you can just use a calculator at this point, or you can do it by hand. On a calculator, let me just write out. On a calculator, you would go 1 divided by 2. That's how you do the fraction. 1 divided by 2 times 25 times 40, and we already said it would be the answer 500. You could do it by hand by taking half of 40. Remember how I talked about that? Half of 40 is 20. 20 times 25 is 500. Either way, by calculator or by hand. Is that good? Questions on that? All right, so I'm going to move on. All this will be on YouTube later. If I go too fast, because I try to teach towards the middle of the class. Some of you will feel I'm too fast, I'm too slow. I try to be in the middle, and then if I'm going too fast, it's on YouTube later. You can check it out. All right, driver who drives at a speed R miles per hour for T hours. Can you see that okay? Will travel a distance D miles given by that formula. Blah, blah, blah. You don't need all those words. Here's all you need. D equals RT.
Yeah, distance equals rate times time.
Yeah, distance equals rate times time. And again, you don't have to memorize those formulas. The test questions will be just like the homework. And the homework is giving you the question, isn't it? So I will do that on the test as well. So the test will be just like homework, different numbers. Distance equals rate times time. And they're giving me speed of 58, 6 hours. So what do I do with that speed of 58?
So you take the 58 times 6, and that'll tell you how far.
Yeah, that's the R, and this is the time, huh? Just plug them in. Remember, we put parentheses around things we're plugging into formulas. 58 times 6. You can use your calculator. 348. There we go.
So that's the answer, is 48.
That's the answer, yep. That's what they want you to type into the box right here. 48. If a car travels, at 58 miles an hour for 6 hours, it'll do 348 miles. All right, I'll keep moving. That's number 2 out of 20.
Is it being recorded now, or?
Yep, we are live right now. Your voice is on there right now. It's true, we are on there. Yeah, it's being recorded right now. By the way, I've also got a whole nother semester where I recorded it. So there's going to be 2 versions of everything. On the YouTube, I've already got all last time I taught this a year ago recorded on there as well. All right, so they're giving me a rectangle, and they want me to find the area. How do you find the area of a rectangle? Anybody know the formula for that?
Length times width.
Yeah, length times width. It's just one side times the other side. Call it length and width, base and height, whatever you want to call it. It's just one side times the other side. It's just 6 times 4, 24. There we go. Good on that. Stop me if you have questions or comments. to do so. All right, so let me bring those words over here so you can see them a little better. To less than in. So they want me to take those words and translate it to an algebraic expression. Let's make it a math thing. Go from English to math. So how do we take 2 less than in, that's English, and change it to math? How do you write that as a math thing?
You would do n minus 2.
Is it n minus 2?
Yeah, because when it's less than you.
Or is it 2 minus n?
No, it's n minus 2.
N minus 2?
Because less than signifies that you switch the order.
Does it?
Yes.
Word then.
Yeah.
Is that right? Does the less than switch the order?
Yeah.
Seems like some of you are pretty confident, but some aren't sure. You know what I do when I'm in a situation like this? Because it's hard to memorize all the math rules, isn't it? In fact, let me just say it straight up. There's too many rules in math to have them all perfectly memorized, unless you teach it every day like I do. If you're just more of a regular person who can keep all these memorized all the time if it's not your job. Well, what helped me when I was a student, because I really don't have that great of a memory, what helped me is to put in real life numbers. I was surprised how much better I thought with numbers than I do with letters. So if I was taking a test and I got some kind of question like this and it was multiple choice and what A was this answer and B was that answer and I was like, oh shoot, I don't know. I don't remember the rule exactly. What I learned is I said, okay, look, what if they said 5 here? Just make that, because I don't think well with letters. I think better with numbers. What if they said 2 less than 5? Then you'd all know exactly what to do, huh? Which one comes first?
5.
The 5 does, right? We all know 2 less than 5 means the 5 comes first, right? We think better with numbers, don't we? So what does that mean? Well, that means if the 5 came first, the n comes first. You guys are right. It is that one, isn't it? So if you're ever stuck on something, just put in numbers. You think a lot better. You and I both think a lot better with numbers than we do with letters. So you're right. The less than does change the order. That's good that you guys already know that. So we'll have to, if you didn't already know that, it is good to remember that if you can. The less than means it goes at the back. The 2 less than, the 2 goes at the back, doesn't it?
Yeah, it's the same thing when you have more than. It's the word than that signifies.
Right, it's the word than, exactly. Because let me change it up. What if they said 2 subtract n? Then the 2 would go first, wouldn't it?
Right.
Right, it's the than that switches the order. Exactly. We all good with that? Questions on that? So you got to watch for those 2 kind of phrases. They'll use either one of those, and the less than goes at the back. All right. Whoops, there's my selfie. I made a video. I have an online class, and so I made my first selfie video last night for my online class. They said they want to see the teacher's face, so I did it. My 17-year-old girl thought it was hilarious of me taking. I've never seen you do a selfie, Dad. That's great. All right. So.
Is it the same class or a different one?
It's a different class, yeah.
Okay.
All right, so 30, what is it? 39 increased by Q. What does increased by do? Can you read that more, make those bigger? Yeah, right, we all good with that? It's add, isn't it? Increased by, so that's just 39 add the Q. Now, could we switch the order? What if we did the Q first and then the 39? Is that okay? Yeah, either one, right? Because the order of adding doesn't matter. Think about numbers again. Numbers are easier to think about. 2 plus 3, is that any different than 3 plus 2?
No.
It's 5 either way you do it. The order of subtracting matters, but the order of adding doesn't matter.
So you can do it either way?
Either way. And Math Excel knows it. It's a pretty user-friendly system. It knows that those are both right. I'll just say or, either one. Because adding, the order doesn't matter. Subtracting, it does. You got to be more careful. Yeah? Yeah, they do get more complex. A little bit.
Those word problems are tricky.
Yeah, we'll have a lot of word problems. Okay, so it says 1 more than 3 times a number. And it wants me to use x. See how it says there, use x as your number? So the number thing, that's going to be x. All right, so 1 more than 3 times a number. 1 more than 3 times a number. What do I do with that?
3x plus 1.
Yeah, what does the more do? Add. The more is add. 1 more, 1 added to. And we already know the order of adding doesn't matter. So you can put that plus 1 at the back or the front. Doesn't matter, right? Order of adding doesn't matter. 3 times a number, 3 times x. You put it that way, or you could go 3x plus 1. Yeah, it says but with adding,
With the adding,
we don't care.
correct. Okay, got
yeah, with the adding, it can go either way.
It's the
On that, yeah.
What I was learning in high school is that if you add a number in front of an actual number, it adds to that number. But in the way I'm multiplying, I'm not sure how that works.
Yeah, I hear what you're saying. It's a good question. Because I think if I'm tracking with you, a good question is, can we just make this 4x?
No.
Right, and what you're saying is right, we can't, huh? In this case, we cannot. Yeah, you can't make that 4x because these are not like terms. We'll get more into that later, but a lot of you already know that. They're not like terms. If that was 1x and 3x, then we could add them and it'd be 4x, wouldn't it? But you're right on. In this case, we can't add because that other one doesn't have an x. It just has to stay just like that. That's right. Good. One less than the product of two numbers. Now, for the two numbers, it tells me right here, use x and y. Okay, what does product mean? Multiply. Product means multiply. So it says 1 less than. There's that than. What does that mean? To the back. The minus 1. Because remember, subtraction matters. Doesn't it? There's a big difference between 5 take away 1 and 1 take away 5. You can't take 5 from 1. So the order of subtraction matters. We have to be careful. So if it says less than, now 1 goes to the back, as we've seen. And then what goes in the front? The product of two numbers. Just x times y. Yeah, when you write them right next to each other like that with no symbol in the middle, it means times, as you know. Huh? So there it is. Good. That's 1 less than the product.
So x and y are the product.
They're the product, exactly. This is the product, because it means times. I'll put a dot in for extra emphasis, but you don't have to. It's not required. Yeah, it means times. Product means times. There is the product. So the less than, the 1 goes to the back. We're getting close to the end of this first section. Number 18, your salary after a 3% salary increase, if your salary before the increase was S, is that a little S? Okay, so 3%, so 3% increase on S. They want me to use S, like X or whatever, as the original salary. So how do we do that? How do we do it? What's the formula going to be? This is considerably more difficult. What's the formula going to be for a 3% increase on S? How do we do that? Anybody know? It's a tricky one.
I think you multiply 0.03
Good.
to the S and then add it to the original S.
Good. 3%. 3%. You guys all know about changing that to decimal. Right, it's going to be 0.03, right? Decimal always goes back 2 places. Fix that. Because the original decimal was right here, wasn't it? And the percent has 2 zeros in it. That's reminding you 2 places back. So 1, and it's to the edge of the 3. 2, and it brings a 0 in, doesn't it? So you're always moving back 2 places. So you change it to decimal, 0.03, good job. Times S. That's exactly right. And then you said also add back another S. Very good thinking. Right on the money. Does everybody know about that? Why? Why am I adding back the other S? Because it's your original salary. This part's just the increase. You know what helps? Real life numbers. Let me just suppose I made, what did I say, $100 tires or whatever.
Do you want
Yeah.
the multiplication next to the S?
Like a times here?
Yeah.
Yeah, that's fine. It's totally allowable. So $100 set of tires, let's say, and we're going to, how would you increase the price? 3%. You wouldn't just take 0.03 times 100. If you just did that, that'd be the 3.
No.
You'd have to also add back the original 100 to make it 103 as the new price. Everybody see that? You've got the original plus a percentage times the original. Do you see what we're doing? Original, I'm going to write the formula. There is the formula right there. Plus percentage of the original. To increase a price, you've got to take the original and add a percentage of the original. So let me write that formula out. Here then is the formula for a percent increase problem. It's original plus percent times original. Now I put the original at the back. Doesn't matter back or front. Remember, it's added. You can put this S in the front if it bugs you. Whatever. Same thing. Everybody see that? Original plus percentage changed to decimal. When I write percentage, I mean, changed to decimal. Times the original. There it is. The common mistake is just to only do that part. But we got to add back the original, don't we? All right, now, there's one more trick. That if I type that in right now, if I type in S plus 0.03S, Math Excel is not going to be happy. If I type that in, Math Excel is going to say, no, not good. Why not? What's wrong with it? Let me ask you this. What if I said 3x plus 4x?
They're like terms.
That'd be 7x, right? You all know that'd be 7x,
Right.
We wouldn't leave it 3x and 4x. We'd say, well, that's 7x, right? If they both have x's, they're like terms. Now, if this one didn't have an x, then we would leave it as 3 plus 4x. We can't add them. You cannot add them unless they're like terms, right? They both have to have the same letters. If they both have x, then we add them in 7x. Well, look here. These both have the same letter. They need to be added. Well, what's the number in front of the first one? An invisible, but understood 1. Yeah, if there's no number in the front, that means there's one S there. There's not two S, right? There's one S. So you have to add the 1 and the 0.03. Just like you have the 3x and the 4x to get 7x, you have to add the 1s and the 0.03s. You have the numbers 1.03s. There's the final answer.
Your original one is S plus
0.03.
S.
Right.
So we're going to put the 1 in front of it. Okay.
Yeah, invisible. There's always invisible ones in front of our letters if we need them. They're always there.
So our answer is going to be 1.03S.
So that is our final answer, 1.03s. Yeah.
Oh, so instead of the S, we just made it into a 1. Okay. Because it's always invisible 1. Okay.
Yeah, there's an invisible 1 right there. And then the two numbers add, and we keep an S. Yep, that's exactly it. So what that means, do you realize that that's a practical thing you can do? Say you're shopping for tires, like I said, or whatever. You're looking at the tires, they're $100, or that's probably cheap for tires, they're probably $400. And there's a, what is sales tax now? 8%, 8.5%? I don't know, something like that in our county. So you think, what's that going to be after tax? And you want to calculate it. How would you calculate the price of a $400 set of tires with tax? Let's say tax is, 8%. What would you do? Now, even with a calculator, I'm assuming you would do this in a calculator, you would go, well, times 0.08, right? And then add back the original 400. Right? Times 0.08 would give you the tax, and you add back the original 400. You could do that. That's right. That's okay. But it's much quicker. It's much quicker to just take the 400 and multiply by 1.08. Do you see what that's what this formula said here? Put the 1 in the front, and it gives you back the original. If you just do one step on your calculator, 400 times 1.08, you see the 1 gives you back the original 400. Because what is this? This is 1 times this 400, isn't it? So it's a quick way to calculate the final price, including tax and everything. That's what we just saw with that formula. If you just put a 1 in the front, it gives you back the original and everything in one step. I worked at, when I was finishing up my master's degree in math, I was at Cal Poly, that area, and I had summer jobs. Every summer I worked for somebody different, trying to keep my head above water financially. I worked at PG&E, and I took bill payments. That was my last summer job before I became an official math teacher. So I was working at PG&E. We were taking bill payments there in San Luis Obispo in the summer, and right before my last year. And we would do this kind of calculation all the time at the counter. People come up to pay their PG&E bill, and there'd be some kind of tax thing, and we'd go, 400 times 0.08. We'd add back the original 400, and we'd tell them their price. And, me and the other clerks, we would all do that. At one point on a break or something, I grabbed the other clerks and I said, hey guys and gals, you can save some time on this calculation. Instead of doing the 400 or whatever to put it and then adding back the original or clearing your screen, they'd write it down, then add back the original. It'd take a lot more time. You can just put a 1 in front of the number. And then one step, that quick, you got your answer. And they were like, no. And I said, well, let me show you. And so I did one long way and I did the short way and boom. And they went, what? They're like, I don't know. That's some college trick. And I'm not, I was the only college kid. They were all, that was their permanent life job. I was the college kid just for the summer. They're like, that's some college trick. I'm not doing that. I'm like, really? Okay. I was trying to help. But anyway, they thought of me as the magician of math or something. Anyway, so it's just to put a 1 in the front. That's all it is. All right.
You didn't say how many hours he drove, though.
It says he drove 47 miles an hour for X hours.
Yeah. So it's just 47 times X.
Yeah. Yeah, remember the formula we saw a minute ago?
This is
Distance is rate times time. So this is the rate. This is the time.
yeah.
So it's just 47x. That's all it is. They're not showing us the formula this time, so it makes it a little harder. They showed us this on an earlier problem. Distance equals rate times time. They want the distance, notice. So then I just put in the rate, put in the time, 47x on that. So it was $34 before spending T on jeans. Had $34, then spent T on jeans. So how much money does Justin have now? So he had $34, and then he spent T on jeans. So how much does he have left now? If you're at all confused, what if you're looking at going, I don't know about that T and what I do. Remember, what's my suggestion? Just say, hey, pretend that's a 10. If you're at all confused, make the letters and numbers. You'll think so much better. What said Justin had 34, then he spent $10 on jeans. What would you do?
34 minus 10.
You'd go 34 minus 10, wouldn't you? So the T is playing the role of the 10. There it is. Make sense? It's just weird how we don't think well with letters, huh? We just kind of, letters are just T. What's T? But if it's 10, you know right what to do. Like that. So that's all they want, 34 minus T. Subtract that amount he spent on the jeans. All right, so there is our first section.